Hi, this video is on some basic integration rules. So you should have a list of the very basic integration rules, and there are 20 of them here. Um, I'm using something very similar. It's the same order where 1 through 20. So if you can look at these, just go over them. And these are basically what we've been going over as far as basic integration. Integration of sine is negative cosine. Integration of cosine is sine, and so on. I like these last three here. If you can make your integration look like one of these three, then the integration is automatic and you just plug the numbers in. Whatever you get for A, whatever you get for U, plug into A and U of the formula here. So let's take a look at three problems. Now, if you look at the denominators in these three problems, they're all the same. The only difference in these problems is problem A does not have a variable, an x on top. B has an x, and C has an x square. So that's the only difference between these problems. There's no x. All right, no x. There's an x, and then there's an x square. So let's look at each one of these three. Well, if you look at this integration, and if we change this, x squared is x squared, and 9 is a perfect square. It can be changed to 3 squared. We also know that if we have a constant up here, we can, if we want, put it in front of the integration. And if I want to, since this is a x squared plus 9, I can have 9 plus x squared. I can put the 3 first. There's nothing wrong with this. So if we now have it in this form, let's go to our basic integration rules again and look at number 19. If you see how 18 has the radical symbol and so does 20, but 19 doesn't. It has an a square and a u square with a plus sign between them and du above it. So if I can make an a and a u and a du out of our problem, which I think I can if we look at it, we're good to go. So if you notice, this is a square and this is u square. So a in our case equals 3 and u equals x. Well, if u equals x, du equals 1. By the way, did I say this should be a 1 here? If we take the 4 out, like we did here, this should be a 1. And the derivative of u is 1. So that makes it a little bit better. So we're in this form. A is 3, and x is u, or u is x. So we're in the exact same form as problem 19 on the basic integration. So if I go back to problem or formula 19 in basic integration, a du a squared plus u squared. So here's the formula: du a squared plus u squared. And if you look at the formula once again, it changes to 1 over a arctangent of u over a plus c. So all we do, we are in this form. Du is 1, our a is 3, and our u is x. And we have a 4 in front. So let's just change this part to this part. So a is 3. 1 over 3. A is 3. Arctangent. That's funny. My R's look like N's and my N's look like R. And I should have a C in there. Arctangent U over A. U is X and A is 3 plus C. So our integration changes to this. And don't forget, there's a 4 sitting out in front. So finally, if I multiply by 4, I end up with 4/3 arctangent X over 3 plus C. So, I mean, there was no real integration there. We used the formula number 19 to create the answer. So that's actually kind of nice. All right, let's try another one. Our second one has the X in it this time. So when we look at this, we end up with so we can't change this to u squared plus 3 squared. I mean, you can try at first, but if you go back to the formula sheet, there's no x on top of any of these. Do you see how there's no x value? So we have to use a different method. There's no straight formula that I can use. So we have to try to use something different than one of these formulas. So when I look at this, then I'm going to now notice that my bottom, I'm calling u is x squared plus 9. And then the derivative of u would be 2x. So I can change this problem to times 2x. That's still 4x on top. You see, I just factored out a 2 out of the top of that. And then I have x squared plus 9. X squared plus 9. Now, if I change this, it can be 2 integrating 2x is the same thing as du, and x squared plus 9 is u. So I'm integrating du u. 1 over u is basically what I'm doing. I'm integrating 1 over u. So if I go to my formula sheets and look up integrating 1 over u, I have it right here in number 5. Do you see du over u changes to the natural log of u plus c? So that problem just changes to the natural log of u plus c. This integration changes to the natural log of u plus c. So I'm going to change it to 2 times the natural log of u plus c. And now if I change it back to natural log of u is x squared plus 9 plus c. And there's my answer. So I did use one of the formulas in the formula sheet, one of the basic formulas. It was just a little different because we had an x and I couldn't use one of those 18, 19, or 20 rules. So I had to recognize that, hey, this bottom is u, and if I take the derivative, I get 2x, x squared plus 9, and the derivative is 2x. And I can form that with this 4x, 2 times 2x. All right, so we have one more to do now. The top is x squared, so this is definitely a little different. Um, when we have the top power and the bottom power like this, more than one x, I'm going to use long division. We're going to use long division. So when the top powers are like this, they're both the same. We can use long division. So on the side, I'm going to use long division. 4x squared divided by x squared plus 9. X squared goes into 4x squared 4 times. When I multiply 4 times x squared, I get 4x squared. 4 times 9 is 36. By the way, since there's nothing up there, I'm just going to add a 0. And we're going to subtract this. 4x squared minus 4x squared is 0. 0 minus 36 is a negative 36. So when I do long division on this thing, I end up with 4 minus 36 over x squared plus 9. Remember, this is 4 with a remainder of negative 36. Another way of writing that from algebra is 4 minus 36 over the divisor, x squared plus 9. So this is what I'm down to integrating here. This subtraction, integrating 4 minus 36 over x squared plus 9. So this is where I'm at. And we can do, since there's a plus or minus separating, I can integrate 4 minus the integration of 36 over x squared plus 9. And what I'm going to do is erase this here in a second and put this back up. But I want everybody to focus just on this part. This is where we're at. And I'm going to erase this. So we are at integrating 4 and then minus integrating 36 x squared plus 9. We can put the 36 in front, integrating 4 minus 36 over 1 over x squared plus 9. Integrating 4 is just 4x, right? We add the x power 1 and put that on the bottom. Integrating a constant is just putting an x there. And then this one, this is once again u squared plus 3 squared. We've done that one already. That was rule number 19, 1 over u squared plus a squared. Rule number 19, 1 over u squared plus a squared. Doesn't matter if the u or the a is first, just as long as there's a plus sign between it. 1 over u squared plus a squared. And u, so on the side, we're going to say u is x and a is 3. So this part integrates problem A. If you remember, this part integrates to problem A, to formula number 19. This integrates to, this part integrates to 1 over A arctangent u over a plus c. So we end up with 4x minus 36 times 1 over a is 3, arctangent, I always forget the c, u is x over a is 3 plus c. And the only thing we're left with is clean that up a little bit. We end up with 4x. 36 times 1/3 is 36 divided by 3, which is 12, minus 12 arctan x over 3 plus c. And this is our integration answer. Okay, so the last thing I wanted to do was just go over these rules. It says techniques, procedures for fitting integrands to basic integration rules. If you had to integrate something like this, the best thing would be to FOIL this, distribute 1 plus e to the x times 1 plus e to the x. Multiply that all out, and you get this, and then integrate. If you had this, you could actually, because of the plus sign, you could separate the numerators, right? 1 plus x over a denominator is the same thing as saying 1 over the denominator plus x over the denominator. So you could separate them because they're being added on top, added or subtracted on top into two fractions, and then you can integrate them separately. This one's kind of important. 2x minus x squared, you can complete the square, and this is what you would get when you complete the square. Then you would have a, and this could be u squared. So with the square root, that's one of those rules, 19, 18, 19, or 20. It's not 19, so it's either 18 or 20. You can take a look at that. You can divide the improper fraction when the powers are the same. Do you see? This is what we get when we divide the fraction. Add and subtract terms in the numerator. In this case, they separate this, and you can see if you can do anything with that. I would take a look because you can look at factors, and I think you could separate this for one integration, because that's a 2 plus 1, and or there's a factor of 2 out of there, and you get x plus 1, and one of the factors down here is x plus 1. If you notice, that's what happened. They did that down here. They separated that. That factors out. And you trig, you could change the identity, and then multiplying and dividing by a conjugate. If you multiply by this by its conjugate, the conjugate is the exact same thing on the bottom, but a different sign. You end up with a different problem, and it might be easier to integrate. If you can't find a rule for this, if you look at your rules and you can't find a rule, now look at your rules of integration for secant square, and this is really similar to u and du. So you can multiply by the conjugate. So take a look at these rules if you're doing homework and all that. These are good basic integration rules. I would have these actually printed out. And it's really good. And so it might remind you, like the problem I did, that to do long division first and then use one of the rules. And there are other techniques that we had here. If you have any questions, feel free to contact me. I hope this video helps.